Physics labs are supposed to be the absolute pinnacle of science class, but the reality usually looks a lot more like this. Before a single measurement is taken, you spend 20 minutes of class time just untangling wires, distributing sensitive equipment, and replacing dead batteries. And because there is rarely enough gear to go around, you end up with groups of 5 students crowded around a single voltmeter. One student does the actual work, while the other 4 check out completely. This leads directly to the ultimate failure of the traditional setup. Because they can't do the experiment themselves, students just wait for the correct data to appear on the whiteboard, or they copy the numbers from the smart kid in the front row. We are left with a system defined by massive setup time, broken gear, and completely copied data. For under-resourced schools, this traditional format creates massive logistical stress for the teacher and generates fake analytical outcomes for the students. To solve these bottlenecks, many educators shift to digital labs, but the software options are incredibly varied. You have heavy, complex 3D simulators. These look fantastic, but they demand high-end hardware and steep learning curves that most school computers simply can't handle. On the other end, you have standard 2D simulations. They are highly accessible, but they operate as open-ended sandboxes. They lack automated grading and have zero mechanics to prevent cheating. PhysHub sits right in the middle. It is a streamlined tool designed specifically for middle school grades 7 through 9. Adopting it means learning a new platform and entirely changing your teaching routine. The question is whether that upfront effort is actually worth the time you save and the accurate data you get back. Direct, clear tone. We are not asking if a screen replaces real-world science. We are calculating if the return on investment actually cures the burnout caused by grading and lab setup. Let's track this on a matrix measuring teacher effort against educational impact. Requiring students to bring devices starts as high effort, low impact. But the outcome? Every student gets perfect virtual springs. Setup time drops to 0, rocketing to high impact. The cost of this efficiency is tactile experience. The student loses physical motor skill development of handling fragile glass or wiring a real electrical circuit. PhysHub trades that fine motor skill practice for absolute conceptual accessibility and hands-on analytical thinking. Now we address the biggest lie in the classroom: copied, fake data. PhysHub uses an algorithm to generate completely unique lab variables, like different weights and distinct spring constants, for every individual student account. It becomes mathematically impossible to copy from a neighbor. To pass, the student is forced to actually apply the formula and do the math themselves. Expect initial friction. You will get pushback from students who are used to coasting to an easy A by copying someone else's work. Enduring a few weeks of complaints is the required price to achieve honest, verified understanding of physics concepts across your entire roster. Finally, we have to measure the toll of checking notebooks. The teacher has to stop manual calculation checking and rely completely on PhysHub's instant automated grading dashboard. Hours of weekend grading disappear. They are replaced by real-time ratings and diagnostics that show exactly where the class is struggling. You have to relinquish step-by-step manual control over grading and trust the platform's formative assessment algorithms to do the heavy lifting. The hours you previously wasted hunting for basic math errors in 30 different notebooks can now be spent actually teaching and correcting deep misconceptions. Let's map this out. Have enough modern equipment? If your school is well-funded and requires tactile skills, stick to physical labs. If equipment is broken or absent, ask, need honest data and faster grading? If yes, adopt the digital model. Digital tools aren't built to kill classical physics. They are surgical tools designed to rescue under-resourced classrooms. The optimal setup is an integrated approach. Assign virtual tools as a pre-lab at home to build the concepts, and reserve class time for the physical experiments you actually have the gear for. The return on investment is clear. The hours spent learning to use PhysHub are paid back in full by the very first weekend you avoid bringing lab books home. Ultimately, it is far better for a student to gain honest conceptual understanding in a digital space than copying fake numbers in a physical notebook.